Beneath the surface of our oceans lies a world that defies every expectation we have about life on Earth. A realm where the rules of biology break down, where creatures exist that seem designed by nightmares rather than evolution. As we journey deeper into these waters, crossing invisible boundaries that separate one zone from another, the animals we encounter become progressively more alien, more impossible, more terrifying. We have sent spacecraft to Mars. We have photographed galaxies billions of light years away. Yet the deep ocean, covering more than 60% of our planet's surface, remains almost entirely unknown. Scientists estimate we have explored less than 5% of these depths. We literally know more about the surface of Mars than we do about what lurks 6,000 feet below our own seas. At the ocean's surface, life seems familiar and welcoming. Sunlight penetrates the clear blue waters, fueling photosynthesis in countless microscopic plants. These tiny organisms form the foundation of vast food webs that support everything from colorful reef fish to massive whales. The surface ocean pulses with energy, color, and recognizable forms of life. But something dramatic happens when you descend just 200 meters below this sunlit paradise. The light begins to weaken, and with it, our comfortable understanding of how life should work. Welcome to the Twilight Zone, a massive layer of ocean that extends down to 1 kilometer deep. Here, the sun's rays are too feeble to power photosynthesis. The underwater forests of microscopic plants disappear entirely. There are no green energy producers, no familiar food chains. Instead, life depends on a ghostly phenomenon that scientists call marine snow, a constant drift of particles falling from the world above. Dead plankton, fish waste, fragments of larger creatures, all of it slowly sinking through the water like an underwater blizzard. To us, these falling particles might seem insignificant. To the creatures of the Twilight Zone, this marine snow represents the difference between life and death. And where there is food, life finds a way to exist, though not in any form we would recognize. The animals that have evolved in this dim realm challenge everything we thought we knew about what living creatures should look like. Many have become completely transparent, their bodies like living glass. The glass squid drifts through the water with its organs barely visible, appearing more like a ghost than a living animal. The glass octopus takes this strategy even further. Its entire body is essentially invisible, with only its dark eyes giving away its presence. Why so many different species have independently evolved transparency in this zone remains one of marine biology's great mysteries. It might serve as the ultimate camouflage, allowing animals to vanish completely in the faint light that filters down from above. Or perhaps, transparency represents an energy-saving adaptation, eliminating the metabolic cost of producing pigments in a world where every calorie matters. But not every creature in the Twilight Zone chooses invisibility. Others have taken the opposite approach, becoming masters of light itself. In the perpetual gloom, some animals create their own illumination through a chemical process called bioluminescence. The displays are absolutely mesmerizing, flashing dots of light, glowing patterns that pulse across an animal's body, entire creatures that flicker like living lanterns in the darkness. But this is not simply beautiful decoration. In the Twilight Zone, light means survival. Some species use their glow to attract unsuspecting prey, luring small creatures toward their waiting mouths. Others employ bioluminescence to find mates in the vast, dark ocean. Still others use light in perhaps the most clever way of all, to disappear. This technique is called counter-illumination, and it represents one of nature's most sophisticated camouflage systems. From below, predators can easily spot the dark silhouette of an animal against the faint glow filtering down from the surface. To counter this, creatures like the firefly squid cover their bellies with light-producing organs called photophores. They continuously adjust the brightness of these lights to perfectly match the glow from above, effectively erasing their outline and vanishing into the background. It is camouflage by imitation, making light to disappear into light. Other species play even stranger games with bioluminescence. The bloody bellycomb jelly produces deep red light. Since red wavelengths cannot penetrate to these depths, the jelly appears completely black to other animals. This allows it to hide any bioluminescent prey glowing inside its stomach, concealing evidence of its meals from potential predators. Subscribe to our channel to journey even deeper into these alien worlds beneath the waves. But the Twilight Zone holds more than just optical illusions and light shows. It also hosts one of the most spectacular events on our planet, though few people have ever heard of it. Each night as darkness falls above, something remarkable happens in these depths. Billions upon billions of creatures begin to rise toward the surface. Lanternfish, squid, jellyfish, and countless other species climb through the water column, ascending hundreds of meters to feed on the plankton blooms under cover of darkness. At dawn, this entire army reverses course, sinking back down into the safety of the depths. This massive movement is called the diel vertical migration, and it represents the largest synchronized migration on Earth, greater in numbers than all terrestrial herds, flocks, and swarms combined. Despite its enormous scale, this daily spectacle remained completely hidden from human awareness until World War II. Naval sonar operators began detecting what they called a false seafloor, a dense layer that mysteriously rose every night and sank every morning. They initially thought their equipment was malfunctioning. It took years to realize they were not looking at the ocean bottom at all, but at life itself, an entire invisible world moving as one. The Twilight Zone represents our first glimpse into the deep ocean's alien nature. Here, the familiar rules of surface life begin to bend and break. Transparency becomes armor. Light is weaponized for both hunting and hiding. Billions of animals rise and fall in an ancient rhythm that predates human civilization by hundreds of millions of years. This is merely the threshold, the first layer of a world that becomes increasingly strange the deeper we go. Past 1 kilometer, all traces of sunlight vanish completely. We have entered the Midnight Zone, a vast realm stretching down to 4,000 meters. Here, there is no dawn, no dusk, no seasons, only endless night. Temperatures hover just above freezing year-round. The pressure is hundreds of times greater than at the surface, enough to instantly crush any surface creature. To human eyes, this seems like a world where nothing could possibly survive. Yet it is here, in this alien environment, that evolution becomes most creative and most terrifying. Consider the dragonfish, one of the Midnight Zone's most mysterious predators. Unlike most deep-sea creatures, it can produce red bioluminescence. This might not sound particularly impressive until you understand that red light is invisible to most deep-sea eyes. The dragonfish has essentially invented a private searchlight, allowing it to illuminate prey without revealing its own position. Even more remarkably, its eyes are specially adapted to detect this hidden color. It operates in a secret wavelength, visible only to itself. Other predators in the Midnight Zone are masters of disappearance. Some fish are covered in ultra-black skin so efficient at absorbing light that it reflects less than 0.5% of any illumination that touches it. Even when a submarine spotlight beams directly onto these creatures, they seem to absorb the light and vanish like living shadows. But perhaps no creature exemplifies the Midnight Zone's strangeness better than the anglerfish. The female dangles a luminous lure in front of her cavernous mouth, using bioluminescence to draw unsuspecting prey within striking distance. But the anglerfish's greatest mystery lies not in its hunting strategy, but in its bizarre approach to reproduction. Male anglerfishes are born tiny, weak, and seemingly helpless. They have one singular purpose in life: to find a female, a nearly impossible task in the vast, dark ocean. When a male does locate a female, he latches onto her body with specialized jaws. His tissues then begin to fuse with hers in a process that can only be described as biological horror. His organs gradually wither away until he becomes little more than a sperm-producing appendage, permanently attached and nourished by the female's bloodstream. It represents one of the most extreme forms of sexual parasitism known in the animal kingdom. Not every creature in the Midnight Zone is an active predator. Many are opportunistic scavengers, waiting patiently for food to drift down from the world above. When a whale dies at the surface and its carcass sinks to these depths, it becomes an oasis that can feed entire communities for decades. Yet even with our most advanced submersibles and remotely operated vehicles, what we know about the Midnight Zone remains fragmentary. For every species that scientists have documented and studied, they estimate dozens more remain completely unknown. Each expedition into these depths returns with creatures never before seen by human eyes. Animals with glowing appendages, needle-sharp teeth, or bodies so delicate they literally disintegrate when brought to the surface. This is the Midnight Zone, a world where light is wielded as a weapon, where invisibility determines survival, and where even the basic processes of reproduction follow rules that seem designed by alien intelligence rather than earthly evolution. At 4 kilometers depth, we leave the open waters behind and encounter the seafloor itself. Welcome to the Abyssal Plains, one of Earth's largest habitats, covering more than half of our planet's surface. Yet it is also one of our least understood environments. The Abyssal Plains stretch like an underwater desert in every direction. No coral reefs, no kelp forests, no towering underwater mountains to break the monotony. Just endless expanses of fine sediment extending for thousands of kilometers. Temperatures never rise above 4 degrees Celsius. Food is incredibly scarce. Survival here demands adaptations unlike anywhere else on Earth. One of the most striking adaptations is size. Many animals of the abyss grow to enormous proportions compared to their shallow water relatives. Giant isopods, looking like enormous pill bugs, scuttle across the sediment, reaching the size of small dogs. Amphipods, normally tiny shrimp-like creatures, can grow longer than a human hand. The colossal squid, among the largest invertebrates alive, prowls these depths with eyes the size of dinner plates. Scientists call this phenomenon deep-sea gigantism, but the reasons behind it remain hotly debated. Some researchers suggest that larger size helps conserve energy in the food-scarce environment. Others propose that it provides better defense against the few predators that exist at these depths. The truth is, we simply do not know why the deep ocean produces giants. Life in the abyssal plains moves at a different pace entirely. The vampire squid, despite its terrifying name, is not a predator at all. It survives by collecting drifting particles of marine snow using long, sticky filaments. Its blood contains a special pigment with the highest oxygen-binding capacity of any known cephalopod, allowing it to thrive in the oxygen-poor depths. Here, time itself seems to move differently. Creatures grow slowly, reproduce rarely, and live for centuries. The Greenland shark, which can dive to abyssal depths, may live over 400 years, the longest lifespan of any vertebrate known to science. Some of these sharks alive today were swimming when George Washington was born. Even the sediment itself teems with hidden life. Each grain hides countless microorganisms, recycling nutrients and sustaining food webs that we are only beginning to understand. The abyssal plains remind us of our planet's true scale. They cover more area than all forests, grasslands, and deserts combined, yet remain largely unseen, unexplored, and unexplained. But the deep ocean has one more surprise waiting. Beyond the abyssal plains lie Earth's deepest scars, the oceanic trenches carved by tectonic forces over millions of years. Here begins the Hadal Zone, named after Hades, the ancient Greek underworld. These trenches stretch from 6,000 meters down to the deepest known point on Earth, nearly 11,000 meters below the surface in the Mariana Trench. To put this in perspective, if Mount Everest were dropped into the deepest part of the Mariana Trench, its peak would still be more than a mile underwater. Conditions in the Hadal Zone push the very limits of what we consider compatible with life. Temperatures remain near freezing. Pressure can exceed 1,000 times what we experience at sea level, enough to instantly kill any surface organism. Yet life not only survives here, it flourishes. Among the most remarkable residents are the snailfish that live at the very bottom of trenches. These creatures appear impossibly fragile, with thin, translucent skin and gelatinous bodies that look too delicate to exist in such a hostile environment. Yet, they are the deepest living vertebrates ever discovered, thriving where no other fish can survive. Their success comes from remarkable adaptations. Their bones are reduced to cartilage, and their cells are reinforced with special molecules that prevent proteins from being crushed under the enormous pressure. They represent evolution's solution to an almost impossible problem. Other trench inhabitants are smaller, but equally extraordinary. Amphipods swarm across the trench floor in vast numbers. Recent studies have found plastic microfibers inside their bodies, sobering proof that even Earth's most remote habitats are touched by human pollution. The deep is not as isolated as we once believed. At hydrothermal vents along the trench walls, life takes perhaps its strangest turn of all. Here, microorganisms feed not on sunlight or marine snow, but on chemicals spewing from Earth's crust itself. Hydrogen sulfide, methane, even dissolved metals in superheated water. Entire communities of tube worms, clams, and crabs depend on these chemical-eating bacteria. It is a food web based on chemistry rather than photosynthesis, showing us that life can exist in conditions utterly alien to the surface world. These discoveries have profound implications beyond marine biology. If life can adapt to such extremes here on Earth, could it not also exist on other worlds? Icy moons like Europa and Enceladus hide oceans beneath their frozen surfaces, warmed by internal forces rather than sunlight. Studying the Hadal Zone gives us glimpses into the possibilities for life throughout the universe. Yet despite its cosmic significance, we know almost nothing about the trenches. Fewer people have visited the bottom of the Mariana Trench than have walked on the moon. Each dive brings back creatures completely unknown to science, from translucent sea cucumbers that drift like underwater parachutes, to gelatinous blobs with no clear anatomy to microorganisms whose metabolisms remain total mysteries. For centuries, humans imagined the deep ocean trenches as lifeless voids, silent underwater graves. What we have found instead is resilience beyond imagination, life that bends, adapts, and reinvents itself to endure the most extreme conditions on our planet. Despite all our technological advances and scientific expeditions, the deep sea remains fundamentally a world of questions. More than 80% of the ocean is still completely unexplored. Each dive into the depths, each robotic expedition, brings back creatures that challenge our understanding of what life can be. We encounter transparent fish whose organs are visible through their skin, glowing worms that produce light through chemical reactions we barely understand, jellyfish that seem to break every rule of biology we thought we knew. It is a world where scientific discovery is not rare but constant, where each expedition rewrites textbooks. Even among the creatures we have studied, fundamental mysteries remain unsolved. Why do so many deep-sea animals grow to enormous sizes? The giant isopods, colossal squid, and hand-sized amphipods represent a pattern we can observe but not fully explain. Why do others become nearly invisible or cloak themselves in skin so black it absorbs virtually all light? These adaptations clearly work, but the evolutionary pressures that shape them remain largely mysterious. Perhaps the greatest puzzle of all is bioluminescence itself. Nearly 3/4 of deep-sea creatures produce their own light, yet the reasons vary wildly from species to species. Some use it for hunting, others for hiding, still others for finding mates or simply surviving. We still cannot explain how so many species independently evolved such complex biochemical systems, or why some glow in colors that no other deep-sea animal can perceive. There are deeper questions that haunt marine biologists. How do creatures navigate in the absolute darkness? How do they find mates across vast distances in a three-dimensional world without landmarks? How do their bodies withstand pressures that would instantly crush surface life? How do entire ecosystems function when primary food sources are so scarce? The deep ocean represents one of the last great frontiers on our own planet. It is a realm that reminds us how little we truly know about the world beneath the waves. Every dive reveals new species, new adaptations, new possibilities for life that we never imagined could exist. These discoveries matter far beyond academic curiosity. Many deep-sea organisms produce unique chemicals that could revolutionize medicine. Others have evolved proteins and enzymes that work under extreme conditions, potentially useful for industrial applications. The deep ocean may hold keys to understanding climate change, as these waters store vast amounts of carbon and heat. But perhaps most importantly, the deep sea reminds us that our planet still holds profound secrets. In an age when we feel we have mapped and cataloged everything, when satellites can photograph any point on Earth's surface, the deep ocean stands as proof that mystery and wonder still exist. The creatures of the depths, with their impossible adaptations, their alien beauty, their defiance of everything we think we know about biology, represent some of Earth's greatest treasures. They are living proof that evolution can create forms beyond our wildest imagination, that life finds ways to flourish in environments that seem utterly hostile to existence. As we face an uncertain future, as human activities threaten ecosystems around the globe, the deep ocean represents both hope and responsibility. Hope, because it shows us that life is more resilient and creative than we ever dared believe. Responsibility, because these incredible creatures and their alien world depend on our protection. The deep sea reminds us that we are not separate from nature, but part of something vastly larger and more mysterious than ourselves. Every glowing creature in the midnight zone, every impossible adaptation in the abyssal plains, every sign of life in the deepest trenches tells the same story: that our planet is more wonderful, more alien, and more worthy of protection than we ever imagined. In the end, the deep ocean's greatest gift may not be the creatures it harbors, but the humility it inspires. It reminds us that for all our technology and scientific progress, we are still explorers on our own planet, still capable of wonder, still surrounded by mysteries waiting to be discovered.